Dear students, today inshallah we're going to start our final revision starting from module 9, 10, 11 and then 12. I'll try to break the final revision into videos. Each video has one module. In module 9 here we have triangle ABC. He's saying it is similar to XYZ. Determine which sequence of transformations maps triangle ABC onto triangle XYZ. Whenever the triangles are similar, like these two triangles here, triangle ABC and triangle DEF are similar, so we say that AB over DE 10 over 5. 10 over 5 is 2, and BC over EF, BC is 16, EF is 8, 16 over 8 is also 2, and then AC over DF, AC over DF is 12 over 6, which is also 2. So they have a common ratio, or we call it the scale factor 2, because it got enlarged. Triangle ABC enlarged from DEF into ABC. Triangle ABC is similar to XYZ, and there are a sequence of transformations. What are the transformations? Let's remember together first. We have rotation. If it rotates 90 degrees clockwise, this is clockwise, or the other way, counter clockwise. And we also have translation. What is translation? It happens when something moves from its place, right, left, up, or down. Right, it affects the x, so it becomes x plus x. We add numbers to the x. Left, we subtract from the x. Up, we add numbers to the y. And down, we subtract units from the y-axis. And the last, or the third transformation is we have reflection. We have reflection either across the x-axis. If I have an image here across the x-axis, it flips upside down. This is the x-axis, so it flips upside down. And if I reflect it across the y-axis, it goes from the right to the left, or vice versa. So this is reflection across the x-axis and reflection across the y-axis. The last thing we have is dilation. We also have dilation. What is dilation? Either enlargement, which makes it bigger, or reduction, which makes it smaller. So we have two things, enlargement, and the second thing is reduction. We also have reduction to make it smaller. So let's see here in this question, from ABC to XYZ, AB, if you notice, it is corresponding to XY. AB was 1 unit, 1 box, XY is 2 units. So there is dilation, it got larger. Which one of them here is dilation? Actually, all of them here are dilation, but which one of them is dilation with scale factor 2? Take care, you should notice all of them. AC is 2 units, it's corresponding to XZ. If you notice that the triangle is just rotated. XZ, how many units are they? 1, 2, 3, 4 units. So 2 times 2 is 4. So if you want to get the scale factor, it becomes the small triangle, maybe AB over XY, or the larger triangle over the smaller one. What is it? What is the larger triangle? XYZ over ABC. So, Mr., how do I start? XYZ or ABC? We start with the triangle that the similarity went to. So it's saying ABC is similar to XYZ, and the transformation maps ABC into XYZ. This is the most important thing. triangle ABC is transformed into XYZ. So I will start up triangle XYZ and down triangle ABC. Now let's see. Triangle XYZ, XY corresponding to AB. So I have XY corresponding to AB, and we also have XZ over AC. Let's put the numbers. XY is 2, AB is 1, equal XZ, which is 4, divided by 2. If you divide 4 divided 2, you will find that the scale factor is 2. So we have two options that are having the scale factor 2. Very good. ABC, did it rotate 90 degrees counterclockwise? Did it rotate 90 degrees counterclockwise? Yes. If you notice, ABC, if we rotated it 90 degrees counterclockwise, it will be the correct answer. And then, so it is dilated, it got larger and rotated to the left, or 90 degrees counterclockwise. Question 2. Which sequence of transformations can be used to show that two figures are similar but not necessarily congruent? What does it mean similar? They have the same shape. Same shape. What does it mean congruent? Same size and shape, or exactly similar. So, same size and shape. Rotation and translation. Which one of them makes them same shape but not the same size? Which one of these affects the size? The only thing that affects the size is dilation. This is the only thing that will change the size. So if I made dilation, this will make it not congruent. Translation and reflection keeps it similar. Reflection and rotation keeps it similar. Rotation and dilation keeps it similar and congruent. The only thing that changes the size and makes it not congruent to the other is dilation. Which sequence of transformation can be used to map ABCD into EFGH? Which one of them is the correct transformation? Let's see. Take care, this question is a little bit tricky. ABC into EFG. So AB over EF. AB over EF equal, if you notice, the order of the letters BC over FG. BC over FG. Let's see these first. AB over EF. AB is 1 unit, EF is also 1 unit, okay? So 1 over 1 equal. Is it equal? We're checking if this is equal. BC over FG. BC how many units? 1, 2, 3, 4. So these are 4 units, and FG is only 2. So 4 over 2. Are they equal? 1 over 1 is 1. Is it equal? 4 divided 2, which is 2. Are they equal? No, they are not equal. So this is not similar. So we can say that no transformation occurs. Okay, triangle ABCD is similar to triangle EFGH. Determine which sequence of transformations maps the rectangle ABCD into rectangle EFGH. Okay, so EFGH triangle EFGH is he's saying it is already similar to the other triangle. They are already similar. ABCD is similar to what? EFGH. So which sequence of transformations here? Is it dilating and translating, or dilating and rotating, dilating and reflection, dilation and rotation? Let's see together again. ABCD is similar to EFGH. If you notice, the order of the points A, B, C, D, E, F, G, H, the same order, nearly the same order. So there is no reflection. There is no reflection. Okay, so we'll cancel option 3. Very good. What about the sizes? What happened to the size? AB was 2 units. EF became 1 unit. Very good. What about BC? How many units are they? 1, 2, 3, 4, 5, 6. 6 units. And here it became 3 units. So what happened if you notice? 2 over 1. We can say like this time. It got smaller because the transformation from ABCD onto EFGH. So we write EFGH at the top and triangle ABCD down. Now let's see the similarity statement. EF AB is similar to EF. So here EF over AB equals another side. Let's say FG is similar to BC. FG 3 units, BC 6 units. Very good. So again, what happened here? FG over BC. This is equal EF. What is EF? 1 unit. AB is 2 units. So 1 over 2 is the same like FG over BC 3 over 6. Let's divide 1 over 2 or 3 over 6. It is already 1 over 2. So there is dilation of scale factor half 1 over 2. So the only dilation scale factor half is this option. So this is the correct answer. And if you notice, the translation is 3 units to the right. It moved to the right 3 units. Very good. Number 5. Which sequence of transformation can be used to show that two figures are congruent? Which sequence of transformation shows that two figures are congruent? We said congruent is anything but not dilation. Anything but no dilation. So dilation, this can't be. Dilation here also, so can't be. So the correct answer is reflection and rotation. Why? Because dilation makes it bigger, it changed the size, so it becomes not congruent. Very good. 9 for similarity and corresponding parts practice. Let's see here in this example. He says ABC similar to EFG. A similar to E, B similar to F, C similar to G. So the question is, angle A similar to what? To angle E. Angle B similar to angle F. Angle C similar to angle G. Very good. Let's see here. Determine whether this pair of polygons is similar. If so, write similar statement. How do we decide if they are similar or not? We have to check the sides. Let's see here. H or GH is corresponding to what? Step by step. Which angles are equal? Look, H has one arc and D has one arc. So if you write like this, you can write like this. H corresponding to D. And then E, 4 arcs, is corresponding with A. So E corresponding to A. F corresponding to B. F corresponding to B. And C is corresponding to G. C corresponding to G. Very good. So this is the first shape. This is the second shape. Let's take 2 of these sides. For example, GH. Where is GH? Sorry, here is HEF. G. This is G. G corresponding to C. Very good. So now if I want to know if they are similar or not, we have HG. HG, for example, is similar to DC. C. Let's divide 30 over, what is DC? 15. Very good, so which is 2. Another side, for example, let's see HE similar to DA. DA, where is DA? Here it is. HE is 28 over DA, which is 14. 28 divided 14 is also 2. They have the same ratio, so we can decide that both of them are similar. Why? Because the two sides are, the two corresponding sides here are similar, and the angle included is also similar. Look, where is the angle included? Angle H is corresponding to which angle? D. So again, if you notice here, you will find that AD corresponding to HE and DC corresponding to HG, and the angle between them is the same, so we say that yes, they are similar, and the order matters. For example, we said that A corresponding to E, A corresponding to E. Where is A? Here is A, and here is E, and also A and E again, and then B corresponding has, B has how many dashes? 3 dashes, so B corresponding to F. Here is B corresponding to F, and then C, 2 arcs corresponding to G, C corresponding to G, and D has only 1 arc and it's corresponding to H, D corresponding to H, so this is the correct answer. Very good. He's saying next, determine whether this pair of polygons are similar. If so, write the similarity statement. Again, you will notice immediately that OL is corresponding to CD, so OL over CD. We want to check if this is equal to ON over CF. Is it equal to ON over CF? Look, OC is 5, CD is also 5. Is it equal to ON, which is 15 over 20? 5 over 5 is 1. 15 over 20 is not equal to 1, so they are not similar. We want to know also if they are similar or not, and we will write the similarity statement. Let's see. RS corresponding to NO. So like this. RS corresponding to NO. Is it equal to RQ over MN or not? Let's see. RS over NO, 12 over 9. Is this equal to RQ, which is 20, over 15, which is MN? With your calculator, divide 12 divided 9 divided 3 divided 3 becomes 4 over 3, divided 5 divided 5, 20 divided 5 is 4 over 3. Yes, they have the same ratio. M is equal to Q, N is equal to R, S with O, L with P. So yes, they are similar. Let's go with the order. L corresponding to P. Yes, L corresponding to P. M corresponding to Q. Yes, M corresponding to Q. N corresponding to R. N corresponding to R here. No, so it's not this option. L, M, N, P, Q, R. Yes. And O corresponding to S. Yes, very good. Next, again, determine whether these two triangles are similar or not, and write the similarity statement. LMN with OPQ. Yes, they are similar or not similar. Again, in the triangles, we have this statement, SAS, side, angle, included, and side. Very good, but Mr. I only have two angles. I don't know anything about the sides. So you have angle N and angle M. Take care. 34, 34. The third one, what would it be? 180 minus 34 plus 34. What would it be? When you use your calculator, it's gonna become 112. And this angle here, what is it? 180 minus 54 plus 54. What would it be? Let's subtract 180 minus 54 plus 54. It is 72. Do you have two similar angles here? Do you have similar angles here? All the angles are different, so they are not similar. Determine whether two triangles are similar or not. Actually, these are not triangles, they are trapeziums. Trapezium. If so, write a similarity statement. K is similar to O, L with P, M with Q, three dashes, N forward and forward. So the angles are equal, but what about the sides? If you notice here, 17 over 21, 17 over 21, yes, it is equal to the other 17 over 21. 17 over 21. So they have the same ratio. So yes, they are similar. What is the similarity statement? K with O, L with P, K with O. Here it is, K with O, L with P, M with Q, M with Q, N with R, N with R. So yes, this is the correct answer. Determine whether the two triangles are similar. If so, write a similarity statement. We have X, Y, Z, V, X, W. We have two triangles. Again, these angles are two vertically opposite angles. So these are two equal angles. But what about the other angles? Are they equal? We only have one angle. One angle is not enough. If I have two sides that are equal, we might say they are equal, but one angle is not enough, so we say that they are not similar. Multi-select which of the following is true about triangle ABC and triangle XYZ. Again, the triangles are similar or not. Let's see. The angles are equal. Okay, C equal to, let's see, zoom in here. C is equal to Z or Y, and B is equal to Z or Y, and A is equal to X. Very good. So let's say that AB is corresponding to XY, and is it equal to AC over ZX, AC over AB over XY, AB over XY, and AC over XZ, XZ, because A is similar to X. And finally here we have CB, is it similar to ZY or not? Step by step. AB over XY, 7 over 3.5. Is it equal to AC over AZ? AC is 7. AC is 7. XZ is 3.5. CB, we have to check all the sides. CB over ZY. CB is what? 6. ZY is 3. 7 over 3.5 is 2. Again, 2. 6 over 3 is 2. So yes, they are similar. All the sides are having the same scale factor. The angles are also equal. A equal X, Z equal C, Y equal B. So yes, the triangles are similar. How does it work? A with X, A similar to X, and B similar to Y, B similar to Y, C similar or corresponding to Z. Yes, very good. And are the triangles congruent? Are they having the same size exactly? No. And this is the sign for congruent. So this is not correct, not correct, not correct. So the only two options, similar, and this sign means similar. What is the value of x? Very good. In this part we're gonna do with cross multiplication. So how do we do this? 21 corresponding to what? To 3. So 21 over 3 equal 14 over x. It will be given in the exam that the two triangles are similar, and you will just work with the corresponding sides. 21 over 3 and 14 over x. Take care, the large triangle first, so 21 up. 14 is the large triangle first, so the 14 also up. Now I want to get the x. We do it with cross multiplication. 14 times 3 divided by 21. 14 times 3 divided 21. So x equal over 21. Calculator, you can use it. 14 times 3 divided by 21, which is equal to 2 units. What is the value of x again? Let's see the corresponding sides or the corresponding parts. What do we have? AB corresponding to A corresponding to D, and B corresponding to E. So AB over D E. Okay, and the one that has an X, FD corresponding with, we know that F corresponding with C, so FD corresponding to CA. Let's put the numbers. AB 8 over DE, where is DE? 12, equal FDX over CA, which is 10. Cross multiplication, 8 times 10 divided 12, 8 times 10, 80 divided 12. There is something we need to fix again. What did we say here? AB is corresponding to, let's check together. Where is A? A corresponding to D, and B corresponding to E. B two arcs, E two arcs. So AB corresponding to DE. Very good. So this is correct. FD, F 3 arcs, C 3 arcs. So F is corresponding to C, and D is corresponding to A. So FD is corresponding to AC. FD is corresponding to AC. So again, AB 8 over DE 12 is equal to FDX, and AC is 10. Okay, now if you did the cross multiplication, you will not get any of these values. If you did 8 times 10 divided 12, 8 times 10 over 12, you will not get any of these values. So what is the mistake? Who can get it here? You should have, for example, the large triangle up and the small triangle down. Mister, if I put the small triangle up and the large triangle down, no problem. But all the sides of the large triangle must be together, and the sides of the small triangle must be also together. What does it mean? Let's see it together. So I will cross this now, and let's do this again. The large one, FD, we said that it's corresponding to AC, correct? So FD corresponding to AC, bravo. And the other side, DE, look, DE, I put the FD up, the large triangle up, so DE also, it must be put up. It's corresponding to what? DE corresponding to AB. Very good. So now I can solve it. FD is X, AC is, what is AC? AC is 10, and DE now 12, D is 12, AB is 8. So now I can do cross multiplication. 12 times 10 divided 8. So here it is, x equal 12 times 10 over 8. Multiply 12 times 10, 120, divided 8 is 15 units. Very good. Solve for x. Again, we need to put the large one maybe up and the small, actually it's not a triangle, and the small shape down. So let's see. Now you have QR corresponding to UX. So 18 over X equal RS corresponding to VW. RS is what? 24. VW is 16. And now, by the way, both of them are similar. Cross multiplication. 18 times 16 divided by 24. 18 times 16 divided by 24. So X equal, multiply using your calculator, 18 times 16 divided by 24 is 12 units. Very good. Again, solve for X. Take care which are the corresponding parts. 2.5 corresponding to 3. Take care which one we will gonna put up. Let's put the large up over the small. All the large sides together up and all the small sides together down. Together. You can pause the video and think of and try to do it. Pause the video and try to do it on your own. Very good. The large one, 3 over 2.5. And this x is corresponding to what? Take care, n is 90, m is 90. So the x is corresponding to the 4.5. Why? Because I have a 90 here and then the 90 here. So you can say that the x is corresponding to 4.5. Bravo, cross multiplication now. What are we gonna multiply? X equal 3 times 4.5 divided by 2.5. So how it becomes? 3 times 4.5 over 2.5, which is 5.4 units. Amazing. The last question in module 9. The two rectangles are scale drawings. What is the measurement of x? We want to know the x. So if you know that, notice you will find that x is corresponding to the 5. Again, the large one up, the small one down. X over 5 is equal to 28 over 7. Cross multiplication. 5 times 28 divided by 7. So the x is equal 28 times 5, 28 times 5 divided by, bravo, 7. Very good. So here we have our fraction, and 28 times 5 over 7, which is 20 units. Thank you so much. See you inshallah in the next module.